All right, so we're picking up where we left off, kind of a rush at the end there, with 9.2, factoring quadratic trinomials. Okay. And we left off with factoring quadratic trinomials where a is equal to 1. We're going to look at a not equal to 1 today. We're going to look at a special case called perfect square trinomials, and also factoring quadratic trinomials. They aren't actually quadratic trinomials, but they are quadratic in form, and we can use a substitution method. The homework that's posted right now is 9.1 from last time, GCF and grouping, and 9.2, which is quadratic trinomials, but there'll be a second 9.2 posted later this afternoon once I get in the computer that will have these other methods that I'm showing after what we ended up with last time. I'll show these other methods. We'll also say 9.2 for their homework, but they have there are a couple special type cases that you may not have worked with before in 308. Okay, so you're going to see two 9.2 homeworks. And then 9.3 is what we'll pick up with them next week in factoring binomials. Okay, so quadratic trinomials. Remember, trinomial is just a 3-term. Oh, one thing, hold that thought, actually. Let me make sure everybody's got their test back. Who has not gotten their test back? Okay, so I've got Manuel, Jacob, Eli, right? No, Sheldon, right? Eli. Oh, okay, sorry. And James, Lauren, Leda, and Veronica. So yeah, we're missing Veronica, Lauren, Chris, and Sarah. Okay. Those were rather close. Okay. Just a note about the test. Please make sure you go through it. There were some areas that were weak overall, and one of those was actually a review area, which from review from 308, which is linear equations, especially knowing when something is no solution or all real numbers, as well as working with fractions and decimals. These are not going away. It's very equation heavy. We've done the graphing and functions now. Most of what we're doing for the rest of the semester is learning to solve different types of equations. But every different type of equation we solve comes back to a basic linear equation. We break down more complicated equations into linear equations. And so that's key, a key skill. And any other areas as well, I tried to do as much corrections and notes on your test as I could. Please read those. Go back over, reflect on what you missed, what you need to work on. All of those skills are going to continue throughout 310 into our final exam and then into college algebra. Okay, so nothing is not fixable, but hopefully, and I don't want to sugarcoat it either, this should be a wake-up call as well. If you're not happy with your grade, those skills aren't going away. You need to, as well as learning new material and absorbing the new material and keeping up, you need to see what better skills do I need to study and be prepared for this material now, as well as going back and reviewing areas that you were weak before and reaching out for help where necessary. With a peer, with me, with another tutor, coming to the open labs. Okay, that becomes your responsibility. I'm here to help and support, but you've got to look and reflect on your test and reach out where you see your weak areas are so that I can help, or that you can, like I said, work with a study group or another tutor, whatever it is that you are realizing that stuff doesn't just disappear. Okay, it's all going to be built on, and we need to go back and look at it. There were a lot of issues too with like notation, like how you know with whether you use parentheses, brackets, or braces. Okay, so some I did a lot of like sort of squigglies. I didn't necessarily count the problem wrong necessarily, or I just took off a point. But if you've got some crazy notation, which happened more than once, and you're not sure what all my squigglies mean, talk to me, because we want our notation to be very clear as well too. Make sure that you put your exam in this last unit if you're doing the binder, okay? Because it's going to be part of your exam prep for your final. So that exam prep unit in your binder is for both your practice tests and for your returns tests. So you have all of those. That'll all be good material for solving for us to store it there, to go back and reflect, and to start studying for your final. Okay. So any general questions about the exam or? Okay. All right. So do spend some time before I see you on Tuesday reading over that, reflecting, looking at the notes. You can reach out to me via email. Or anytime next week if there's specific things you want to go over. And some of the big topics I saw that were weak, I'll be bringing them up, reviewing as we go along, and where they come up and keep being used again. Okay, back to the task at hand, factoring quadratic trinomials. All right, so we're dealing with any three-term polynomial is a trinomial. Tri meaning three, you've got a three-term polynomial. There's an infinite number of possibilities, three-term polynomials. The only specific ones we can factor are of this form. They are quadratic. They have a quadratic term. This is the quadratic coefficient. It's just a number. And our quadratic term means it's a variable squared. And then we have a linear term. This is our linear coefficient. B is some number. And then the x doesn't have, it has an exponent of 1, so it's linear. And then plus a constant. Okay? So anything in that form may be factorable, as long as it's not prime. And when it factors, it's going to factor into two binomials. And those binomials will start off with x's. Those x's may, I'll leave a little space because those x's may have coefficients depending on whether the x squared has a coefficient. And then it's either going to be plus or minus. And then it's going to be some number. I'll use k for constant, since we already use c for constant here. So k is just another way to write constant. So this is x plus or minus a number, x plus or minus another number. This is just an algebraic way to write the form of these two binomials. A quadratic trinomial factors into two binomials, period. When you're factoring a quadratic trinomial, this is your goal, to break it into the two binomials. And now this arrow goes in the other direction, too. Because if you have two binomials, you can FOIL them, multiply them using FOIL, and you should get back to where you started. You can always check your work. You start with a polynomial, which is a sum, and factor it into two binomials. Or you have two binomials, and you multiply them together using FOIL to go back to your polynomial. Okay? It's all, you can check your work in either way, no matter what you're asked to do. Okay? Now, if you have something of this form, then the way to factor it, picking up where we left off last time with a couple of the more basic examples, is say x squared plus 12x plus 27. Got our quadratic term, our linear term, and a constant. This is a quadratic term, trinomial of that form. We know it's going to factor into two binomials. Now, there's lots of different methods for factoring, and factoring trinomials specifically. If you have a method that already works for you and you're happy with, or you like the one that the textbook shows, or videos you've seen show, I don't care what method you use. I'm going to use a very straightforward, consistent method because I find it's the one that overall works for students the best and really keeps things organized. That doesn't mean you're required to use my method if you've already got one working for you. So I use an ACB method, and I use this X, or this cross, in order to organize so my brain sees what I'm doing better and can keep track of what I'm doing. So ACB, A, B, and C are just our numbers. We're ready to crunch numbers. When we see it's quadratic in form, we're just going to be crunching numbers. A, B, and C are numbers. And so the ACB method means we need an AC, we need to know our AC, and we need to know our B. Our AC literally means A times C. So what is my quadratic coefficient? It's 1. Yeah, in front of the quadratic term, a coefficient of 1. And my C is 7. Yeah. So A times C is, in this case, 7. Okay. And if your A equals 1, then it is always just your C. But I consistently use ACB because when A is not equal 1, it's going to be using the exact same method. Okay, so I want to show you how consistent that is. So in this case, 1 times 27, and our B, our linear coefficient, is 12. Okay? It's just what you see there in the middle. Okay? Now, another thing to note, and I'm going to go ahead and draw my organizing chart here, which is the X with the times and the plus. And my AC, I want to find a magic pair of numbers that multiplies to make my AC and adds to make my 12. Okay? Yes. But hold that thought, because this is a simpler version, but I want to show how, as we get to more complex ones, it's the same method. The other thing I want you to consider is this. You want to consider what your sign pattern is going to be. Okay? Because your two binomials could be two pluses, two minuses, or it could be a mix of plus and minus. And that helps keep the number straight as well. This right here, your C, okay, is the same thing as your L when you FOIL your two binomials. Okay? So if your C is positive, what's the only way to get a positive number when you multiply?
Positive times a positive.
Or negative times a negative. So if you have a positive C, the only way to get that positive product, that K1 times K2, when your L in FOIL, Okay? That gives you that a positive product is 2 pluses or 2 minuses. Okay? So if you've got a positive C, you know you've either got 2 pluses or 2 minuses. How do you know whether it's 2 pluses or 2 minuses?
12, and say equal
Yeah.
positive.
Yeah. Because remember, your middle term, your B, is a sum. It's a sum of O plus I. Okay? So if these are both positive, then it's a positive something X plus a positive something X, which will give you a positive B. If these are both negative, then negative times negative gave you that positive C, but a negative something X plus a negative something X will give you a negative B. Yeah. So with the positive C, you've got 2 pluses or 2 minuses. This tells you 2 pluses. Some people even like to go ahead and write in the form of the final answer, I've got X with no coefficient. That's the other thing. If A equals 1, you know these are going to be X's, because X times X equals, yeah. And if there were coefficients here, then we'd have an A that wasn't 1. So these have to be naked X's. Okay? And we know our sign pattern is 2 pluses, and we're just looking for those magic pair of numbers that go right in there that are going to multiply to make 27 and add, O plus I, add to make 12. 9 and 3. Okay? So I can leave those positive. It doesn't matter the order they're in, 3 times 9, 9 times 3. Okay? This helps my I see. Positive 9 times positive 3 is indeed 27, and positive 9 plus positive 3 is indeed 12. Okay? So that goes right into, and it doesn't matter the order. X plus 3, X plus 9 is the same. Order of factors doesn't matter. Okay? And you're done. Okay with that? All right, so try this one. X squared minus 9x minus 36. Remember, what's the first thing you always ask yourself? GCF, right. Don't make the baby cry. That's on the PowerPoint. Okay. So always a GCF. And the GCF might be a variable, it might be a number, or it might be both. If you got an A equal 1, then at most you'll have a variable GCF. There's not one, but it's always the first question. Okay. And if you don't have that, then you can go ahead. You note that this is quadratic, so you find your ACB. AC is? Right, mind your negatives and positives on that. Negative 36, and your B is? Yeah. Now, before you crunch those numbers, we'll put the negative 36 up here and the negative 9 here. Look at your original, what you're factoring, and what is your sign pattern going to be for your binomials? Okay. Sorry? Both negative? Negative, positive, mix, right. The only way to get that positive C is you multiply a positive times a negative. So does it matter what the middle term is? No, you're going to have one positive, one negative. Now when you add a positive and a negative, you may get a positive sum or you may get a negative sum. Adding a positive, negative, it just depends on which number is bigger. It gives you make a positive answer or a negative answer. Okay? So a negative C means mixed signs. You can even put that in, a positive and a negative, just to remind yourself. Okay? Yes?
Doesn't it matter when C is negative but B is positive?
No, it doesn't matter as far as your magic numbers. One will be positive and one's negative. Now, to get a negative 9, you can add a positive and a negative, and you get either a positive or a negative answer, depending on which one's bigger. So if you're getting negative 9, then which one has to be bigger, the positive or the negative? The negative, yeah. Because adding a positive plus a negative is like finding the difference between them. Okay? And so if the bigger one, the absolute value of the bigger one is negative, that's going to make it a negative answer. If the absolute value of the answer is, if the answer is positive, that means the absolute value of the bigger number was positive. So you're really looking for the difference between two numbers here. Two numbers that multiply, one positive and one negative, multiply make negative 36, but one positive plus one negative. So you got some big negative number and some smaller positive number that add to negative 9. And what does that give you? Yeah, 12 and 3, which one's bigger? Or which one's negative, I should say? 12, yeah. So negative 12 and positive 3. Okay. And double check, yes, those multiply to make negative 36. And the add, see if you add a positive and a negative, you're just finding the difference between them, which is 9, but the bigger one gives the answer the sign. Okay. And so that means that your B might be positive or might be negative. It could go either way. If you've got a negative C, you've got a mix of signs. It doesn't matter what this is. It's still going to be one positive, one negative, which can give a positive or a negative B. So the order doesn't matter in your factors, but what sign it is does. So we've got x plus 3 and x minus 12, or x minus 12 times x plus 3. But it's important that the 3 is positive and the 12 is negative. And you can always check your work. X squared, check. O plus I, negative 12 plus 3, negative 9, check. Negative 36, check. You do a little mental foil and check your work. Now before we move on to the next one, let's go ahead and look at the calculator skills. This one, when you have a equal 1, especially with smaller numbers, and it's even with smaller numbers when we have a not equal 1, the more you can do those factor lists mentally, the better off you are. It's more efficient. If you put everything in the calculator, it becomes a crutch and it really slows you down. Okay? So this one you can figure out mentally, but still I want to show you the calculator in case you get stuck or when we get some really big ones. Okay? Just when you practice this at home with your homework, remember, as much as you can do it mentally, do so to get more efficient that way. All right, so the setup is this. If you go to y equals, okay. Now this is in this y2, and you can just leave it in y2 for right now. Okay? You may need y2 for something different later, but for this unit, you can just leave this there. So what this means is you're going to have 3 columns. You're going to have an x column, a y1 column, and a y2 column. The first thing here is to find out your factor pairs. The first 2 columns are for your factor pairs. And so your factor pairs are whatever you can multiply together to get your AC. So you do your AC, in this case, negative 36, and you want to know what it can be divided by, because factor pairs are also divisors. Okay? So negative 36 divided by x is going to give you 2 columns, an x column and the y1 column. X column is what the calculator chooses, and the y1 column is just going to take negative 36 and divide it by those x's, and those will give you factor pairs that multiply to make negative 36. Then even easier is to put in a third column called y2, which adds those 2 columns together. So all you have to look for is your b. And so you get that. I'm going to clear that to show you how, if you don't have it already entered, how to enter it. You need to add the first 2 columns, and the first column is x, so you put in an x, and you're adding it to the second column, which is y1, so you do plus, and now you need to know how to enter a y1. Okay? Go to vars, right here, under the arrows, that's the variables. Okay? And you need a y variable, so arrow over to highlight that. And now all you have to do is push enter, enter, because when you push enter, you're choosing a function. Yeah, you're not getting into parametric and polar right now, so enter. And then yes, you want y1, so just push enter again. It's already highlighted. Now on the handout out of my math lab, it's here, right here. To get this right here, vars, y vars, enter, enter. Okay. So if you don't have it in there, you can put it back in there another time if you erase it. Okay. So now when I go to my table, I don't care, I'm doing this graphing thing, but I don't care what the graph looks like. That would be a nonsense graph. I want to go to table, which is above graph. Second graph gives me the table. And you can see here's your factor pairs, x and y1. Calculator puts in x, and anything, you ignore the ones with decimals. For example, negative 18 times 2, of course, that's negative 36. Okay? And all other variations. Let me scroll down so I start with 0. Because the calculator is going to put in all these steps of x, positive and negative. Now, since I have this third column, I'm just looking for the 2 things that add up to give me my negative 9. So am I going to scroll up or scroll down? Yeah, because my b's are positive going up and negative going down. Oh, there's negative 9. Okay. So when I add these 2 numbers, I get negative 9. 3 times negative 12 gave me negative 36. 3 plus negative 12 gives me negative 9. Okay. Make sense? Okay. Like I said, using it for ones like this, it becomes a crutch. You want to develop, if you're using it for ones like this, you want to really work on developing those mental math skills. It just makes things more efficient as you go along. This is a good backup, and we're going to do some with big numbers that I use the calculator for. Okay. There's always ones the calculator is just more efficient to use it for if you understand why it works and what it means. Okay. Okay, so try this one. 3x squared y minus 6xy minus 51y. What's the first thing you ask yourself? What's that? GCF, right, always. Where do you start? Ask about a GCF. How do you know you're done? When you have nothing but linear factors. Or at least if you don't have linear, you've checked them to see if they're prime. You can see up here, we have linear factors. So if there's no exponents, linear, they're degree 1, there's nothing else to do. Here, that's what we want to end up with, but where we start always is if there's a GCF. Is there a GCF here? What is it? Y is part of it. There's there's a variable GCF. They all share. And what else? And 3. It also has a numerical one. Yeah. It might just have a numerical GCF or just a variable GCF or a mix. But anything they all share must be pulled out first before you can make any other decisions. Now remember, with the GCF, when you divide that out, you write your GCF and immediately put up a parenthesis. Now you divide out and all the leftover bits go in the parenthesis. So we have, yeah. Now you can easily see that 3 is a GCF of these two, so remember you can just do, you can do 51 divided by 3 to make sure, I mean you can't have a GCF bigger than 3, because remember it's always the smallest one or smaller, so it's either 3 or nothing. Obviously it works there, but if you're not sure about 51, just divide it and it works too. And it leaves behind a 17. Okay. Now normally when we factor quadratic trinomials, we get 2 binomials, 2 factors. How many factors will be in this answer? 3, or up to 3. Is 3y part of the answer? Yeah, it got factored out, we're done with it, but if this is not linear, which it's not yet, we may be able to keep going. So where do you start? Always with a GCF if there is one. How do you know you're done? When you have nothing but linear factors or prime nonlinear ones. So that 3y we're done with. I might even go ahead and write the form of the final answer just so I don't forget about it, because sometimes you want to set that aside so it doesn't get in the way, but don't forget about it. I forget about it, so I always write the form of my final answer. That's my brain glitch. Okay? You find your strategies and where your brain glitches by doing your homework and saying, this is something I always mess up. What kind of strategy, so you don't forget, can you do? So I always make sure I write the form of my final answer so I don't forget that GCF is part of it, but I'm just done with it right now. Now, I'm going to have naked x's because I have no coefficient. Oh, this looked like a not equal to 1, but nice, GCF made it a equal 1. I even personally, I cross out my original one. Not because there's anything wrong with it, but I don't want to choose my ACB from up here. That's another glitch I have. So I want to make sure this is my ABC on this new one. This is done, set it aside, and here's my ACB that comes out of that. What's my sign pattern? Yeah, negative C means we have to have a mixed sign pattern. These are little things that you do, these little things, it's like, this is good, like you want to do everything mentally, it moves faster. A lot of times having these little written tricks actually makes things move faster because you avoid careless mistakes. It's a way to check your work as you go. Because if you just go real fast and don't write things down, but you check your work at the end and it's wrong, it's like, well, where did I mess up? And that slows you down. So these little checks and balances as you go actually is more efficient. AC, B, and I know my sign pattern is plus minus, so I might do this just so I recognize when I'm looking for that pair of numbers, one positive, one negative. Now you can use your calculator, but that'd be a little overkill for right now. What are the think of factor pairs of negative 17. There aren't very many.
Yeah, like negative
Yeah.
1 and
Yeah.
17.
Yeah. 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 Because it's what kind of number is it? Prime number, yeah. So it only has one factor pair. So if 1 and times negative 17, well, 1 and negative 17 or negative 1 and positive 17 don't add up to negative 2, and they don't, right?
So it's just,
Yeah. So there's no magic pair of numbers, okay? Well, that means you're done. That means that this right here is prime. Yeah. Okay? So no K1 and K2, or no magic pair of numbers as I call them, which is not a technical math term. No magic in math. So that means I did the setup so to keep organized, but in this one it turned up that I'm done. Now, does that mean I answer the word prime?
Yes.
Okay.
No magic numbers? Or no,
Right.
that's your answer.
This is right. Yes, because you were able to do something. Now, if you were just given that, yeah, your answer is prime because you weren't able to do anything to it.
So because of the 3.
Mm-hmm. Yeah, you were able to do something, and so that's your answer. It's not prime, but you know you're done because how many factors do you have?
3. Perfect. 4. 1.
You had a GCF, and then how many is this?
1.
Just one. Anything that's in parentheses, remember, its own chunk? Yeah. This is because this means 3y times this chunk. This is 2 factors. Now, if we had been able to factor this, we would have had 1, 2, 3 factors. You're always going to have 2 factors if it's factorable. A binomial times a binomial. And if you pulled out a GCF, then you'll have 3 factors. A GCF times a binomial times a binomial. So you ended up with 2 factors because you had a GCF, but the trinomial that was left behind was not factorable. So you know where to start by looking for a GCF. You know where to end when each of your factors is prime. If your factors are linear, you know they're prime. You're good. But if your factor still has a variable in it, an exponent in it, then you may be able to keep going. And you have to ask yourself, can I keep going? And if you can't because you find it's prime, you're done. That doesn't mean the whole thing is prime if you could do something else. Okay? But that means that you're done. When each of your factors is prime, you're done. You know they're prime if they're linear, but if they're not linear, you have to check. And in this case, checking said, can't do anything. That part's prime, but I was able to do something, so the whole answer isn't prime. The whole answer was I could only take out a GCF. So here's my factored form of this, has 2 factors.
so only if it didn't have a 3 in front of the x squared, then it would be prime? Like only
No, if you could still take out the y.
Okay.
Yeah, you might have just been able to take out a y. If there was no 3 here, you could only take out a y, and then your answer would be that. Yeah,
Only if it
no
had-
3's, yeah.
Okay.
Mhm, yeah.
No extra stuff.
If you can divide out anything, number, variable, or both, then that's a GCF. And that's a factor, so your whole thing isn't prime, but what you're left with, if it still has a you're left with prime factors. And if there's nothing you can do at all, no GCF, and you can't factor it, then you just say it's prime. Prime means I can't do anything. It is prime as is. Okay. Otherwise, if you do anything, that's part of the answer, but you know you're done when everything is prime, either linear or prime. Then you know I have to stop now. But until you figure that out, you have to say, can I keep going? Can I keep going? Can I keep going?
So you cannot keep going is prime.
If you cannot keep going, you're done. If you couldn't do anything at all, you just say it's prime.
From the one up there,
This one right here? Yeah. Yeah, if you couldn't do anything at all, then it's prime. But we could do something, so it's not prime. But we know we're done because what's left now, what we have factored, there's nothing non-prime to keep factoring. So that tells us we're done. If you couldn't do anything at all, you just say prime. But this is something